Hello, everyone. Uh, could you please confirm me if we are live and you can hear me and you can see my screen as well? Okay, very nice. So, yes, let's start. So, this session is basically ISRO and ICRB PYQ questions. And in this particular session, we will be focusing on 2015. The questions that came in 2015 from thermodynamics and its applications. Okay, so we will be covering a few more years, 2015, 16, and later years as well in next classes. But today our aim is to cover all the PYQs from thermodynamics and its applications in the year 2015. Okay, so let us start. Okay, so just to give you a brief introduction, my name is Vipin Kumar. I have done my MTech from IIT Kharagpur. I've also done MSc from Politecnico di Milano, Italy. And I have around 5+ years of teaching experience. Okay. So I hope you would have gotten a little bit of idea. Okay. Thank you, Dinesh sir. Jaya, hello. So yes, let's move ahead. Let's move ahead and start the session. And so the topic that we are covering today is thermodynamics and its applications. So basically it consists of basic thermodynamics and applied thermodynamics. So all the questions from RAC, power plant, and IC engine as well is covered in this particular session. Okay, so let us come quickly on the question slides. Now this is the question. What does the question say? It says that the difference between two specific heats, what is the specific heat? Cp and Cv is equals to R by J. Now what is Cp? This is specific heat at constant pressure. What is Cv? It is specific heat at constant volume. Yes. Jaya, I am not sure about that. We will see. We will see. I don't think it will be private. It will be there. Okay. I am not sure about this. Okay. Let's go. But it's better to be here and just uh, try to do the questions with me. Okay. And we will finish it as quickly as possible. Okay. So let's see. Cp by Cv is equals to R by J. I hope you all know that what does this relation is valid for which particular type of gases. Any gas, like it can be valid, you can apply it anywhere, whether real or ideal, or pure gases or perfect gases. So I hope you all understand this, that this is the Cp minus Cv. This is what we defined for ideal gas. Okay, ideal gas. So ideal gas R, what is R here? R is universal gas constant. Universal. I think you are all aware with this equation, universal gas constant. Okay. And the value is 8.314 kilojoule per mole, kilomole Kelvin. Okay. Now you have to remember this thing. This is only valid. This is particularly valid when there is no intermolecular forces. Intermolecular forces are negligible, or no intermolecular forces between molecules. Okay. Now there is one more equation that you may not have heard, okay? But Cp minus Cv is equals to R by J. And this is also valid for ideal gas, but here sometimes intermolecular forces play a role. Okay. Now what is J here? J is gas constant per unit mass. Okay. So J is gas constant. This is specific gas constant per unit mass or molar mass actually. Okay. So this equation is also valid for ideal or perfect gases. Ideal or perfect gases. Okay. You cannot apply it to real gases or pure gases or just any gas. Okay. It is valid for perfect gas. Yes, that is correct. Okay. Now let's move ahead. Now this is a very simple question. Very simple question. Let's read the question and try to. I hope that you will answer it before me. Now a process in which no heat. What is important here? No heat is supplied. No heat is supplied or rejected. Basically, it is saying no heat transfer. No heat transfer. This is first condition. From the system and entropy is not constant. What does it mean? Delta S is not equal to 0. So we two conditions are there. First, no heat transfer. So if it is no heat transfer, what is the process? If there is no heat transfer, what do you call that process? Anyone quickly? If there is no heat transfer, what do you call that process? That process is called as no, not D. D is basically isothermal only. Okay. So if no heat transfer, then it's simple. It's adiabatic. Okay. Adiabatic process is characteristic it itself that Q is equals to 0. Okay. Now what is reversible adiabatic or isentropic? What is isentropic? Reversible adiabatic, right? But here you have to satisfy two conditions. What? Q is also 0 and change in entropy is also 0. So that means isentropic is wrong. Now isothermal, there is no restriction on heat transfer. This is also not correct. Hyperbolic is a variation of isothermal itself. Okay. Now polytropic is the process where you can have both the option. You can have Q is equals to 0 as well with delta S is not equal to 0. So you can have both the process. I mean, basically polytropic is the most generalized process which have no restriction on any particular type. So here there is no restriction. Pressure is constant, volume is constant, heat transfer is 0 or not 0. Okay, so there is no restriction. Yes, that is true. Polytropic is the answer. Okay, I hope we are all okay. We are all on the same page, right? Chalo, let's move on to the next question. Now, Carnot cycle has maximum efficiency for polytropic is similar to closed system. What do you mean? Polytropic is a simple process. Okay, we apply it in a closed system, yes, but it is the most generalized process. Okay, all the processes can be derived or simplified from polytropic process. Constant pressure, constant volume, adiabatic, isothermal, anything. Okay. Now, quickly tell me the answer. It is the most simplest question. Carnot cycle has maximum efficiency for. Very simple. Quickly. A, B, C, D. What is the right answer? Yes, very nice. C. Carnot cycle is basically, it is only valid for reversible engine, first of all. or it is also called as reversible cycle, and it defines the efficiency for reversible engine. Now any engine other than reversible will have less efficiency. Any other engine will have efficiency less than reversible engine. So yes, correct. C is the correct answer. Very nice. Let's move ahead. So this is the question based on steady flow energy equation, or it is also called as first law of thermodynamics for open system. Okay. So these type of question, wherever you see a turbine, wherever you see a compressor, you see a heat exchanger, you see a pump, you see a nozzle, diffuser, all these devices, wherever you see, you have to apply steady flow energy equation. Simple. Okay. And I hope that you are all aware of what is steady flow energy equation. Okay. Now, this is a turbine. I can see this turbine because it is expanding here. Okay. So there will be work output here. Now, these are the inlet conditions. The inlet and outlet conditions of the steam for adiabatic steam turbine are indicated in the figure. So this is in H1 velocity, potential difference, pressure, and this is out. If the mass flow rate of the steam through the turbine, so mass is given as 20 kg per second. The power output of the turbine, that means work output, I need to find out. Okay. So basically it's simple. We have to apply steady. Let me just okay. Now let me apply steady flow energy equation in this adiabatic turbine. Again, they have said specifically what it is adiabatic. What do you mean by adiabatic? What do you mean by adiabatic? Q is equals to 0. Q is equals to 0. Okay. Now let us try to solve this. So applying steady flow energy equation. What is steady flow energy equation? Mass flow rate H1 plus V1 square by 2 plus GZ1 plus Q in is equals to M dot H2 plus V2 square by 2 plus GZ2 plus W dot out. W dot out. Okay. Now they have said it is adiabatic process. Adiabatic, they have told me. That means Q is equals to 0. So I can cancel this. Okay. Rest I know everything. What mass is basically 20 kg. It is 3200 plus 160 square by. Now always remember one thing. It is very important thing. What? If enthalpy is given in kilojoule, then you have to take 2000 here. If you are taking 2, then enthalpy you have to take in joules. Very important. A lot of people make this mistake. They do not take care of the units. Okay. So because enthalpy is given in kilojoule, you have to take 2000 and plus 9.81 into यहाँ पे we have to take 1000 is equals to again 20 H2 is how much? 2600 plus 100 square by 2000 plus 9.81 into 6 upon 1000 plus W output. So here I can write 20, 3200 minus 2600 plus 160 square minus 100 square. Are you solving it with me? You have to give the answer before I write all this. By 1000, 10 minus 6 is equals to work output. So have you solved this? Tell me quickly what is the answer. Now it's very simple. Nothing is just. Can you tell me what is the answer quickly? I'm waiting for your answers. So what is the answer? The answer that you are going to get is 12156.79 kilowatt. But they have asked in megawatt. You see, they are saying in megawatt, in megawatt. So what will I do? It is 121. I'm sorry, 12.156 megawatt. So this is the correct answer. 12.156. That is A is the correct answer. Okay. Chalo. Let's move ahead. Next question. A solar engine based heat engine, solar energy based heat engine that receives 80 kilojoule of heat at 100 degrees Celsius. So basically you have a heat engine. You have a heat engine. Let us draw heat engine. So this is your heat engine. It is solar based. Okay. It is solar based. Now it receives heat at 80 kilojoule and at 100 degree Celsius. It also rejects 70 kilojoule at 30 degree Celsius. They are asking the thermal efficiency of this heat engine. Yes, Shweta, that is correct. 12, that was in kilowatt, but you have to convert that in megawatt. Okay. Now, the thermal efficiency of this heat engine you have to calculate. Now, see, first of all, you have to know it is a heat engine. That means it is a work producing device. It is a work producing device. It will be, of course, producing some work output. Okay. Now, what is the efficiency? What is the efficiency of heat engine? Efficiency of heat engine or any engine is basically defined as, I will tell you the most general definition: desired output upon required input. Now, what is the desired output from a heat engine? What do you want from a heat engine? You want work output. You want work output. For example, what do you want from a compressor? Compressor, you want to increase the pressure energy. Similarly, what do you want from a turbine? To give you work output. Okay, to give you work output. What do you want from nozzle? Increase in velocity. So basically there is a desired output. For a heat engine, the desired output is net work output. So basically desired output is W out. Now in order to get this work output, what do you need to give? You need to give heat. So what are you giving? Q in. Q in. Okay. Now How do you calculate work output? Work output, you do energy balance. I hope that you are all aware of this concept, energy balance across this heat exchanger. So energy in is equals to energy out. Okay, what is coming in? Q in is coming in. What is going out? Work output plus Q out. Okay, so this is 80 is equals to work output plus this is 70. So work output is equals to 10 kilojoule. 10 kilojoule. So now you can substitute here 10 by 80 and you will get efficiency of heat engine is equals to 0.125 or 12.5%. Okay, is it clear? Is it clear? Of course, when you are solving in the exam, you do not have to do all these steps. I am doing all these steps because I just want you to know the concepts. Okay, so basically work output you can directly calculate by 80 minus 70 and 10 during exam, but it's very important to know the concepts. Okay, knowing the concept is very important. Okay, now so the answer is C. Let's move on to the next question. Okay, now this is the refrigerator. Carnot cycle based refrigerator operates between. So now you have what? You have a refrigerator, and it is operating between 250 and 300 Kelvin. So basically, the higher temperature is 300 Kelvin, and the lower temperature T lower is equals to 250 Kelvin. This is T higher. Okay. T higher. Its coefficient of performance. Its coefficient of performance I need to find out. Now you see, it is a refrigerator. It is a refrigerator. Now refrigerator is a work absorbing device. You see, it is anti-clockwise. It is a work absorbing device. So now the purpose of refrigerator is to transfer heat from lower temperature QL. So it has to transfer this QL from lower temperature to this higher temperature, and for this it requires some work input. It is a work consuming device. It is a work consuming device. Okay, now again, how do you define COP? Same formula, desired effect upon required input. Now as I told you, what do you want from refrigerator? What is the purpose of refrigerator? The purpose of refrigerator is to extract this QL so that this space can be maintained at lower temperature. For example, your fridge, your refrigerator in your home, you try to maintain it at lower temperature than surrounding. So continuously you have to extract some heat. What is that heat? QL. QL must be extracted any way possible. Okay, so desired effect is to extract QL. Now in order to extract this QL, what do you want? What is the required input? Work input you have to give. Work input you have to give. Now again you will do a energy balance across refrigerator. Across here you will do a energy balance. What is this? Energy in is equals to energy out. Okay, energy in is equals to energy out. So energy in, what is going in? You see QL is going in plus W in is going in. What is going out? QH is going out. So what is work input? QH minus QL. So I can write QL upon QH minus QL. Okay, but still I am not able to find out COP. I need to find out COP, right? So COP I can find out by, I know it is a Carnot refrigerator. I know it is a Carnot refrigerator. And for Carnot refrigerator, T1 by T2 or TL by TH, T lower is equals to Q lower by QH. This is there is a derivation for it, but you can prove this. And therefore you can replace this here. So now COP is equals to T lower upon T higher minus T lower. So what is T lower? 250 upon 300 minus 250. So 250 by 50, and the answer is 5. So what is the right answer? Hana Toast? The right answer is A. Sorry, the right answer is B. 5. Okay, not A. Is it clear? The right option is B. Is it clear? Yes, no? Tell me very quickly. Let's move ahead then. Chalo. Very nice. So now a large diesel engine runs on a stroke cycle. I think it is 4-stroke. There is a problem here on a 4-stroke. It runs on a 4-stroke cycle at 2000 rpm. 2000 rpm. The engine has a displacement of 25 liters and a brake mean effective pressure of this. It consumes 0.018 kg per second of fuel with a calorific value of this. Determine the brake power. So I hope you all remember the formula for brake power. So brake power, just 1 second. So brake power can be determined through two formulas. Brake power. Okay, so it is basically the actual power that is available at crankshaft. Okay, it is the actual power. So when we reduce the friction losses, we get brake from indicated power, we get brake power. Okay, so brake power is 2 pi nt by 60, or in terms of mean effective pressure, I can say brake mean effective pressure into swept volume into number of cycles per second. So which formula we can use here? Of course, we'll use this formula because most of the values are given in this way. Okay. So what is brake mean effective pressure? It is 0.6 into 10 to the power 3 kilojoule, kilonewton per meter square, kilopascal. Okay. Into swept volume. Swept volume is, it is given in liters. I have to write it in meter cube. So it is 25 by 1000 meter cube into number of cycles. So that is RPM. So it is given in minutes. I have to convert this into seconds. So I will divide by 60. Now, because it is a 4-stroke engine, I have to multiply it by 2 as well. Okay, so once you solve this, you will get brake power is equals to 250 kilowatt. 250 kilowatt. The right answer is A. Got it? Got it? Yes or no? Chalo. I hope it is clear. Okay. All these questions you have to in less than 1 minute. It is very important because that is a deadline for any PSU exam. Okay, it is not a gate exam. All these questions you have to do in less than 1 minute. So formula should be on your tips. You have to know which formula to apply. Okay, you have to you already have to solve so many questions that you can skip the unnecessary steps while solving in the exam. Okay, so always skip unnecessary steps. I am writing everything because I just want you to explain the concept. Otherwise you do not have to write all these steps. Okay, chalo, let's move on to the next question. And the next question says, a gas having a negative Joule Thomson effect when throttled. So what do you mean by throttling? What do you mean by throttling? Throttling is basically expansion at constant enthalpy. Expansion at enthalpy is equals to constant. Isoenthalpy expansion also you say. What do you say? Isoenthalpic expansion you can say. Okay. Now, so I hope that you all have seen the Joule-Thomson effect diagram, Joule-Thomson coefficient diagram as well. Okay. So let's see. What is the diagram? Now, what you do? You try to draw temperature and pressure with constant enthalpies. Okay, so you fix your enthalpy and then you see how your temperature and pressure is changing. Okay, so what is enthalpy? Enthalpy is equals to U plus PV, and what is this? CPT plus PV. Okay, so you only vary your temperature and pressure and see that and keep your enthalpy constant, and then you draw these curves. So these curves look like this. Okay, and these are all isoenthalpic curves. What do you mean? That enthalpy is constant here, enthalpy is not changing on the curve. For different curves, enthalpy is different, but on a particular curve enthalpy is same. Now you see this peak where enthalpy goes to where this temperature goes to maximum. If you join all these points, it is called as inversion curve. Inversion curve. Okay, and here at these points, mu, Joule-Thomson coefficient, is 0, and on this side mu is negative, and on this side mu is positive. Okay, mu is positive, and this region is called as heating zone or heating region. Now why is it called as heating region? Just I give me 1 second, I'll explain. And this is called as cooling zone. Now why it is called as heating region is that, for example, let's say you are here, and you throttle. What do you mean by throttling? Throttling means reducing pressure at constant enthalpy. So now if you reduce pressure, that means you will go in this direction. If you reduce pressure, you will go in this direction, but you have to go with constant enthalpy. That means you will travel on this curve. Okay, so basically you see here, if you are in this heating zone, your temperature is increasing. Earlier your temperature was this, T initial. Now your temperature is T final. So temperature is increased. So you are doing expansion, but your temperature is increasing. Now, similarly, if you are on this cooling side, so for example, you are here and you do throttling. If you do throttling, then what will happen? Of course, pressure will decrease. So you have to go to this side, but at constant enthalpy. That means you have to travel on this curve. So now you see here, your initial temperature was this, and your final temperature is this. So your temperature is decreased. So you understand this. If you are in heating zone and you do throttling, then your temperature increase. Okay, let me write it here. Let me write somewhere. In heating zone, where mu is negative, throttling will increase the temperature. Okay, and in cooling zone, that means in what region? Where mu is positive. So throttling will decrease the temperature. So now what is the question saying? You are it is saying when mu is less than 0 means mu is negative. So if you throttle, your temperature is going to increase. That means your gas will become cooler, warmer, or same temperature, or either be cooler. Can you tell me what is the right answer? It will become warmer because temperature is increasing. It will become cooler when mu is positive. It will be at same temperature when mu is equals to 0. Okay, I hope it is clear. Got it? Chalo. Let's move ahead with the next question. The pressure P of an ideal gas and its kinetic energy E per unit volume. Kinetic energy per unit volume are related by the relation. How are they related? It's a very simple question actually, if you remember the concept. So basically, you see, I hope that you have all have heard about kinetic theory of gases, and you can say that kinetic energy is equals to 3 by 2 RP. I hope that you all have heard this formula. You all have seen this formula. Okay. Now, you see it is ideal gas. You see it is ideal gas. So because of it is ideal gas, I can say PV is equals to nRT. PV is equals to nRT. Now I am taking N is equals to 1 mole only. So I can say PV is equals to RT. So I can replace PV RT with this. I can say kinetic energy is equals to 3 by 2 PV. So P is equals to 3 by 2 kinetic energy per unit volume. So kinetic energy, they're asking kinetic energy per unit volume. How is it related? It is related by, oh, it is 2 by 3. I'm sorry. It is 2 by 3. When it will go that side, it will become 2 by 3 kinetic energy per unit volume. So I can write P is equals to 2 by 3 E, where E is equals to kinetic energy per unit volume. So this is the relationship. So I think D is the correct answer. 2 by 3 E. Okay, clear? Is it clear? Chalo. I hope it is clear. Let us move on to the next question. So basically, you see, to solve ISRO questions or ICRB questions, your concepts must be clear. Okay, because most of the questions are from concepts. If you know the concepts, they are not, very tricky or very difficult calculations are required. They're all based on concept. If you have given some time to the concepts, okay, not just blindly, remember the formula and start solving questions, but if you have gone deeply into concepts, understood the concept, then these questions are actually nothing. Okay, so again, focus on the concept rather than just remembering the formula and just trying to solve, put the values in the formula and try to solve something, because it is not how it is going to work. Got it? Chalo. Next question. It's a very general question. Your finger sticks to an ice tray. Just take when you take out that ice tray from the refrigerator, your finger sticks to it. So which factor has the more effect on the phenomena? Which factor has more effect on this phenomena? Can you answer this? I you all may have seen this. You all may have seen this phenomena. So do you know what is the concept that comes into play? Quickly tell me. Just try to guess what could be the right answer quickly. Just try to guess what could be the right answer. What do you think works? Which property, which factor works when you take out that tray? So inside temperature of the freezer, but how is it? Because inside temperature is not affecting your temperature. Okay, you're not spending too much time into the freezer that temperature is affecting you, the temperature of the finger. Okay, so I don't think that is the correct answer. Humidity, it is a factor but not so much. Okay, if very high humidity is there, then it may affect but not a very high factor. The heat capacity of both your finger, now also, yeah, that is also a factor, but the most important factor is thermal conductivity. You see what actually happens. You see, look, when you touch that ice tray, so basically heat transfer happens. Heat transfer happens from your finger to the ice tray or the ice. Okay, now in this heat transfer, which factor is important? Thermal conductivity. Thermal conductivity. Now, because this heat transfer that is happening, now your finger is at higher temperature. Okay, so because of this heat transfer, what will happen? Some of ice will melt and it will result in a thin film of water, okay, between finger and ice tray. Now, but you see that ice temperature is still very low. Okay, so because of very low temperatures, the water layer, the film or water film will freeze again, and it will make a icy bond between your finger and the ice tray. And that is the reason that you feel that sticky sensation. You feel that sensation that, like that your finger is attached to that ice tray. It is because of this. Okay. So the answer is thermal conductivity of the tray. Thermal conductivity of the tray. Also, this is responsible to some extent. This is also responsible. All another, of course, these all these factors related to the heat transfer. But the most dominant factor is thermal conductivity. Most dominant factor is thermal conductivity. Okay. Now let's go to the next question. Okay. Now again, this is also a conceptual question. Wet clothes are hung on a clothesline outdoors in a sub-zero weather. What do you mean sub-zero? Negative temperatures. Okay. Negative, less than zero. Less than zero. After a day, the clothes are brought into the house and are observed to be dry. The process of drying is best explained by. How can you explain that the clothes are dry in a sub-zero weather? Now you see vaporization. What is this vaporization? Vaporization is basically conversion of water or liquid into vapor. Okay. So, and it will only happen if, for example, for water, if temperature is greater than zero. Okay. Now melting. Melting basically happens when conversion of ice or solid into liquid. Now, if it is converting to liquid, it is not helping us anyway in our clothes drying. Okay. What is condensation? Condensation is basically conversion. It is basically opposite of vaporization. Okay. Conversion of vapor into liquid. Now again, this is also not helping me in the drying of the clothes. So what is the only phenomenon that is helping? Sublimation. Sublimation is what? Conversion of liquid, conversion of solid, basically solid to gas directly. Conversion of solid of gas. Now it actually happens, and this phenomena is basically endothermic. That means it absorbs heat. When this phenomena happens, it absorbs heat, and that because of that heat absorption, the clothes will get dry, and it will only happen when temperature and pressure exist below triple point of water or triple point. Okay, so it can work. This phenomena can work in sub-zero temperatures. This can work in, because of course triple point is less than the zero temperatures. Okay, so I hope it is clear. Let's go ahead. These are all conceptual questions. Little bit of concept is applied. Now, the question is saying a 10 kg ice. We have ice 10 kg ice at 100 degrees Celsius, and the specific heat is this, is immersed in 40 kg of liquid. So now we have dripped in some water, some liquid, and it is 40 kg, and it is just 20 degrees Celsius with specific heat. So Cp of liquid is 4.0 kilojoule per kg degree Celsius, and Cp for solid is equals to 0.8 kilojoule per kg degree Celsius. Estimate the temperature after a long time if the container is insulated. Specific heat of water is given 4.18. 4.18. Okay. So basically temperature after a long time. Now what is happening here? You see, let me take it to the other page. Now you see this solid is at higher temperature. Okay, solid is at 100 degrees Celsius and water is at 20 degrees Celsius. So what will happen? Two bodies are coming in contact and there is a temperature difference. So the heat transfer will happen. Heat transfer will happen. So heat transfer is basically heat, or I can say heat rejected by the solid will be is equals to heat absorbed, because energy balance must always be valid. Heat absorbed by liquid. So Q rejected by solid is equals to Q absorbed by liquid. Now all this is happening at constant pressure, because you see atmospheric pressure is constant, P is constant. So I can say M C dt of solid, and I can also say M C dt of liquid. Yes. So what is mass of solid? It is 10 kg. What is C? 0.8. What is dt? By initial temperature is 100. Final I don't know. Final I don't know. Is equals to mass of liquid is 40. C is 4. Again final I don't know. But initial is 20. Initial is 20. Okay. So if you solve this, you will get what? 800 minus TF is equals to 4 for 16, 160. TF minus 20. Okay. So if you move ahead and solve this, you will get 21 TF is equals to 500 and TF is equals to 23.8 degree Celsius. This is what you are going to get. Okay. So the final temperature. So you see, solid temperature is going down. The final temperature attained by the solid is 23.8. Liquid temperature is going up, and the final temperature it will reach as 23.8. Okay. Your correct answer is 23.8. So basically 24 degree Celsius. Okay. I hope it is clear. Now, let's go to the last question for today's class. Similar question. A steel ball of mass 1 kg and specific heat 0.4 at a temperature of 60. It is dropped into 1 kg water at 20. The final steady state temperature I need to find out. Very simple question. Very simple. Same question that we solved earlier. Q rejected by steel ball will be equal to Q absorbed by water. So M C dt of steel is equals to M C dt of water. Now what is mass? Mass of steel is 1 kg, C is 0.4 and initial temperature is 60. I do not know the final temperature. Now this mass is again 1 kg. C is, what is C of water? You should know this value. For water, if they do not give, it's your fault if you don't know this value. Okay. C of water is 4.18 kilojoule per kg. Kelvin. Okay, so 4 point, you have to remember this value. Even for air, if for air Cp, Cv and R, for air you need to know. Okay, if you do not know, Google it. And the final temperature minus 20. So little bit of calculation when you do, you will get Tf is equals to 23.5 degree Celsius. Okay, 23.5 exactly is given, so A is my correct option. Okay, so I hope it is clear. I mean, again, I would tell you for any PSU exam, whatever it is, bar, ISRO, ICRB, or whatever exam is there, concept must be very strong. If you just do not remember the formulas and try to, put the number in that formula and try to calculate something, these questions are very short question. You should be able to solve them in 30 to 45 seconds. Okay, not more than that. Okay, because sometimes the question will get stuck, so you will take more time. But most of the questions you should be able to solve in 30 to 45 minutes, 30 to 45 seconds. Okay, and that can only happen if your concepts are strong. If your concepts are not strong, then I don't think that, I mean, you will get stuck for sure. Even if you remember some formulas and try to put the values, but you will not get ahead. Okay, because most of them are not based on formulas, or even if they are based on formulas, you need to know the concepts. Okay, so I hope that today's class was useful for you. Okay. Yes, it's basic question only, right? It's very basic question. But again, it's conceptual questions. Like what we saw today is there were 3 4 questions that were based on our real life. Okay, what we actually see around us. So that is very important to observe, and that you will only understand once you know the or understand the concept, not just remembering that what is the definition of first law of thermodynamics, what is the definition of entropy, what is the definition of second law, what are the statements, what is the definition of internal energy. No, it is not going to work. You need to understand the concept. What do they actually mean? What is the significance of them? Okay, and try to observe them around you. Okay, the phenomena that you learn in because thermodynamics and heat transfer is a subject that you can easily apply around you. Everything that is happening around you, you can observe, and you can relate it to thermodynamics, and especially heat and mass transfer. Okay, so I hope this session was useful to you. I will see you in the next session. I think we will go ahead with 2016 question paper of ISRO, and we will again focus on all the questions that they have asked. Okay, chalo. So I'm going to stop here. I will see you soon in the next class. Bye bye. Thank you.